Hi, I'm Sander van Heyningen, and for my thesis I studied the topic of the impact of reducing road space on car use, and then in particularly modeling the changing travel behavior in response to road capacity reductions. Well, first of all, why did I perform this research? Many cities in the Netherlands want to go from the car-dominated city to the low-car city. As well as the municipality of Rotterdam, where I collaborated with for this research. One of the possible measures to take to go into the direction of the low-car city is to close off streets for car traffic or reducing the number of lanes. Actually, many cities in the Netherlands now struggle with this measure. The effect of closing or redesigning streets is currently uncertain. And this is actually because, first of all, there can be an increase in traffic congestion after the implementation of a road capacity reduction. However, what's also often observed is an overall reduction in car use after the implementation, and this is also known as disappearing traffic. And current traffic demand models, they often overpredict the impact of a road capacity reduction on traffic congestion. This leads me to my main research question, which is how can the change in travel behavior be accurately predicted following road capacity reductions in urban areas, and what insights can be drawn from these predictions? Well, first of all, I started with a literature study to get to know more about disappearing traffic and also the impact of a road capacity reduction on the traffic congestion in the city. And this literature study showed that the traffic congestion usually returns back to its normal state after a road capacity reduction is implemented. Well, to explain this a bit further, I constructed the diagram starting with the implementation of the capacity reduction in the road network. This is actually just less space for car traffic. And this might increase the traffic jams in your city in first instance. However, when the traffic jams in the city rise, people are going to adapt to it. They're going to change their travel behavior because they want to minimize the travel time. And this can result in that people change from car to cycling or public transport, which results in a car use reduction. And when the car use is reduced, this can lead to a reduction in traffic jams in your city. And what you actually see now is a kind of adaptation period, which takes more or less 4 to 5 months. And after that period, a new balance is found between the traffic congestion in your city and the car usage in the city. Then I continued with constructing a predictive model to predict the impact of a road capacity reduction. And this predictive model actually imitates the adaptation period I just told you about. And this is actually an iterative cycle of 3 steps, starting with the traffic simulation itself. Therefore, I used the dynamic traffic simulation of the city of Rotterdam for this scenario where you can implement any road capacity reduction in the network you like. And then for the first iteration, you start with your original traffic demands. Well, you run the simulation and you get updated traffic or travel times over the network. With these updated travel times, you can check whether there's already a new convergence where the traffic is already stabilized, or if that's not the case, then you can recalculate the traffic demand. And in this last step, you actually calculate the number of car trips that change to cycling, public transport, or choose a no-trip alternative. This last no-trip alternative includes people that work from home more often, change their destination outside of the city center, or change their departure time outside of rush hour, since this model is only for the evening rush hour. Well, when the traffic demand is recalculated, you can start the new traffic simulation with your updated traffic demand. And in the end, you will find a convergence with a new traffic congestion, which is more or less the same as you've observed previously. I also researched a case study in the south of Rotterdam, the Roosknoop roadworks. Roosknoop is an intersection in the south of Rotterdam containing of a main corridor, the Laan op Zuid corridor, which is an important road in the direction of the city center, and this intersection also has some smaller side streets attached to it. The Roosknoop roadworks consisted of two different phases. First of all, phase 1, where only the side streets of the main important roads were disconnected, and in phase 2, the more intense phase, the overall intersection was blocked for car traffic. Well, first of all, phase 1, there were no observable differences in car use. However, in phase 2, a significant reduction of at least 4,400 car trips in the evening rush hour was observed. And what's interesting is that after phase 2, they went back to more or less the situation of phase 1, and then the traffic did not fully grow back to its intensity before the implementation of phase 2. This leads me to my overall findings of my research, which is, first of all, a road capacity reduction can indeed lead to a reduction in car use, and the traffic will stabilize after a certain adaptation period. Well, the impact of road capacity reduction can be predicted through iterative modeling, and this then also should include a no-trip alternative to make the model more flexible. Even more, this model also showed that mainly short trips within the city, they are more likely to change their modality. For example, they use the cycling more often, or they use public transport more. However, longer trips, they often change their destination, departure time, or trip frequency. And this was it. Thank you for your attention.